Alright guys, so in 8.4 we're going to take a look at our first algorithm that we're going to use in order to set up a priority list so that we can go ahead and make a schedule. In fact, we're going to look at one of the potential solutions for that Martian habitat unit that we've been talking about building for the last few sections. In fact, we're only going to really look at two different algorithms. We've got what's called the decreasing time algorithm, and then in 8.5 we'll talk about what's called the critical paths algorithm. So with the decreasing time algorithm, our first attempt to build a good priority list is to formalize what is seemingly sensible and often use strategy. In other words, what we want to try to do is do the longer jobs first and leave the shorter jobs for last. In terms of a priority list, this means that the strategy is implemented by creating a priority list where the tasks that are listed are in decreasing order of their processing times. So what does that look like for our example we've been looking at? Well, let's go ahead and see. So here, if you remember, is the digraph for our schedule that we're looking to do for our Martian habitat unit that we are building. There are 15 tasks, and we're going to list them in a priority list based on the decreasing time priority list. In other words, we're going to look for what is the absolute largest time, and that's going to be this AD8 right here. So when we're writing out our priority list, that would be the first thing that we would list, would be AD8. Next highest would be 7, so either AP7 or IW7. So we'll list those next. After that, we can go ahead and start to list out the 6s. So that would be AW6, FW6. I think that does it for 6s. So now let's go through and do 5s. AF5, IF5, and then we also have ID5. And then let's see, I think that's it for 5, so let's do 4s next. So that would be PL4, and then IP4, and then HU4. And I think that does it for 4s. So next we would do 3s, PU3 is right here. PD3 would be next right here. Then we'd have EU2, and finally IC1. So when you make your priority list, which is, again, remember, kind of the most important part about scheduling, this is what that looks like. Really, the rest of it is just the normal priority list kind of scheduling that we did in section 8.3. So this is kind of the one part that's unique or that's different when we talk about the decreasing time algorithm, is how we make that priority list, which if you notice is also on this next slide. So if you need to copy that down, here is that priority list listed one more time. So let's talk about how to use that now to do our schedule. In fact, they've already gotten this one started for us. So here was our priority list. It looks like AD was assigned to processor 1, AP to processor 2. That means that AW6 is ready as well, and AF5 is ready as well. So let's go ahead and let's actually fill out this schedule, which is actually what happens on the next few slides. But let me kind of talk you through what you would be working through. So let's see. At time equals 7, so right here, it looks like AP7 is done. Now when AP7 finishes, that does not open up any other tasks. It would almost open up IF5, but AF5 has to happen first. So nothing new is ready. So at this point, we assign our next task, which is AW6 to processor 2. So that's going to go right in here. And we are counting by 2s, so that would actually put the end of it right here. So that would be AW6, so it is currently working. Now, AD will finish at time equals 8. So at time equals 8, AD is done, AW is currently being worked on. That means that processor 1 is free. And with AD being finished, ID5 would have opened up, but we still have those other kind of preliminary tasks that have to go first. We have to do IF and IW before ID5 can open. So at this point, the only thing that we still can do is AF5, so we will go ahead and assign that to processor 1, and that's going to take a total of 5 hours. Remember, you are counting by 2s, so that would end up being right here at time equals 13 that AF5 would be completed. Now, if you notice, at time equals 13, you're going to have both AW and AF5, which are going to be completed. So let's go ahead and mark off what we've done so far. So at this point, if you look at the tasks which are now available to be started, IF5 has now become available. It's already finished all of its prerequisites. But until IF5 is done, we can't do IW7 and we can't do ID5. So nothing else is available. Let's go ahead and assign what we can. So IF5 is going to be assigned to processor 1. It's going to take 5 hours, so it will be finished right here. Notice that P2, though, has nothing to work on. While IF5 is working, P2 is just going to have to sit idle. In fact, they're going to have to sit idle all the way up until this 18-hour mark. At which point, IF5 is done, so we can go ahead and cross it off. So now let's see what's became available. So now that IF5 is done, PL4 is now available, so I'm going to go ahead and circle it. And IW7 is now available as well, so I'm going to go ahead and circle it too. Now, those are the only two which are now available. Obviously, ID, IP, and IC, all of those are ones that will have to be finished after PL4 and IW7 are working. So let's go ahead and start IW7. That's going to go to our first processor. I'm going to show that that's working. So IW, and that's for 7. So 2, 4, 6, 7 would be finished right here at 25 for the time. Now PL4 is also going to be working. That's going to be right here for processor 2. So both of those are currently being worked on. Now, at time 22, IW7 is still working. PL4 is now done. So PL4 is now done. Unfortunately, though, that does not open anything up for us because notice that IC1 has to be completed after HU4. So once again, for that short amount of time here, for those 3 hours, AP is going to have to sit idly by. Or not AP, but processor 2 is going to have to sit idly by. Now, at time 25, IW7 is now completed. So we are now done here. That now opens up ID5 and IP4. So both of these are now available to be worked. So for processor 1, we'll go ahead and assign one of those. Let's go ahead and assign that to ID5. So that will be finished up right here. And then IP4, we are going to assign to processor 2. So that's going to be right here. Now, at time of 29, IP4 is now complete. So we are now done with this right here. Now, while that does not open up PU3, because notice that ID still has another hour to finish that up, it does go ahead and open up HU4 as an option for us. So at this point, since processor 2 needs something to work on, we're going to go ahead and assign HU4 to that, and that's going to be for 4 hours. So that's going to go from 29 up to 33, which is going to be right here. So that is currently being worked on. Okay, so now let's take a look at time 30. We've got HU currently being worked on, but processor 1 has now just finished ID5. So ID5 can be crossed off. We're done with that. That now does open up PU3 because we had IP and ID that are both finished up. So PU3 is now available. So let's go and assign PU3 to that slot, and that's going to basically take us right up until 33. So PU3 is being currently worked on. Now, at this point, at 33 for our time, PU3 has finished, as has HU4. So both of these are now complete. That actually opens up 3 different tasks that we can do. We can now do PD3, we can do EU1, and we can do IC1. Now, FW6 can't be completed till IC1 occurs, so we're going to still have to wait for that. But we can at least assign PD to processor 1, and at a time of 3 hours, that'll be finished right here at 36. We can also assign EU, since that would be the next on our priority list, to processor 2. So that would be right here with EU. All right, so now at time 35, we have EU that's just finished, so that is now done, and PD is still working. It's got 1 more hour to go. So at this point, IC1 is the only other available task, so we're going to go ahead and do that right here. I'm just going to draw in an arrow since it's a little small to write in there, but that would be IC1 that's currently happening. Now, at time 36, IC1 has just finished, as has PD3. That leaves us with just one task that's left, which is FW6. Since both processors are currently idle, it does not matter which one we assign it to. Let's just go ahead and assign it to our first processor. And that won't be finished until 42. Since there are no other tasks, processor 2 is going to sit idle for the last 6 hours, and then FW6 is finally done. So here's our schedule, but it probably doesn't leave you with a very good feeling, because if you look at it, we had an idle time right here, idle right here, idle right here, for a total of 2, 4, 6, 8, 9, 10, 12, 14 idle hours for processor 2. So yeah, not probably something that makes you feel very good about this schedule. Really, there was kind of one part in that schedule that was kind of unfortunate for us, and that came at this point of the 33-hour mark. In fact, I'm going to kind of highlight that in blue right here. At that point, we had PD3, EU2, and IC1 to work on. Now, our priority list said that we had to do PD3 and EU2 before we could do this IC1. But notice that IC1 is a lot more important to have done because we had to do it before FW6. Think about if we had done IC1 and maybe PD3 here, then you could have started your FW6 at least an hour earlier and finished working on P2 or PD3 and EU2 in that time. So that was kind of a critical point, was where really that amount of time was really important. We should have probably used IC1, but again, that was our priority list. That was what we were working with, and this is how we ended up. So these next few slides, if you want to read through them, basically kind of talk you through, again, kind of step by step what we just did. So I'm going to go ahead and skip over those slides. If you want to go back and take a look at them, again, they just kind of will talk you through and show you step by step kind of where everything was that I was just discussing. So this actually tells us where the finished product is. So notice again, with 2 processors, we ended up with a finishing time of 42 hours, which again ended us right here. Now the weakness of the algorithm was at time 33, and I think I mentioned that to you guys earlier, where we had PD3, EU2, and IC1, and both processors were available, ready to go. And so what we ended up having to do was we had to pick the 2 longer tasks, which were PD3 and EU2, when IC1 was a much more critical task because we couldn't start FW6 until we had finished IC1. So, had we looked ahead and saw which of the tasks were precedent, we might have noticed that instead. So, an even more blatant example of the weakness of decreasing time occurs at the very start of the schedule, when the algorithm does not take into account that AF5 would have a very high priority. Well, and why is that? If you go back and look, AF5 is one of the 2 tasks that must be finished before IF5 can be started. And IF5 must be finished before IW7 can be started, and that has to be finished, and so on down the line. In other words, if you go back and look at our diagram, we waited and waited and waited for IF5 because we figured that, or AF5 rather, because it was not the largest amount of time based on the 4 that we started with. But notice that AF5 had to be done before IF5, which had to be done before all these other tasks. In other words, how we looked down the line to see kind of where we needed to go, AF5 should have happened a lot earlier than it did. It probably should have been one of the first 2 tasks that we assigned, either right here or right here. Now, what we're going to do in the next section is we're going to look at a different algorithm known as the critical paths algorithm, which is going to look at exactly what this idea struggled with. Is we're going to look on down the line to see where do we want to end up and work our way backwards, so to speak, to the tasks at the beginning. So until then, have a good rest of your day.